Rates of change. We need to write this as a derivative. So because something's increasing, derivative will be positive and it's with respect to time. So it's dr by dt is equal to 3, and that's a positive value for the increasing. In this one, something is decreasing, so we need a negative value. So again, it's the rate of change of r with respect to time. So dr by dt is equal to -2. This time it's the surface area that's increasing, and again it's with respect to time. So ds by dt is 0.8. The rate of change of volume with respect to time, so if we use v and t, so dv by dt. The rate of change of radius with respect to time, if we're using r and t, then dr by dt. The rate of change of volume with respect to radius, v and r, so dv by dr. And we can connect these three derivatives together using the chain rule, and just to check, it appears as though the dr's cancel, so we've got dv by dt, which is on this side, so that's correct. If dx by dy is 2/3, then dy by dx means we have to flip over both sides, so 3/2. And likewise with this derivative, if you flip over both sides, then dr by dv will be 1/4 pi, and it's still a minus. We can put the minus there. What's the missing derivative here to complete the chain rule? Now we have a dt here on the left hand side. It's missing on the right, so I know that should be a dt. There's no dx on the left, so that dx has to cancel out somehow, so I need a dx there. Okay, in this one there's a dt on the left, there has to be a dt on the right. There's no dx on the left hand side, so I need to cancel that dx out, so I need a dx here. So they would cancel to give dv by dt. Okay, I need a dt here. There's no dm on the left, so I need a dm here, so the dm's would cancel to give you ds by dt. Example 3. The area of something circular is a function of radius, so dA by dr is 2 pi r, so we're just differentiating this. dr by dt is given, and here is the problem that we need to solve. We need to find dA by dt at the instant when r is equal to 3. So we have three derivatives that we can connect using the chain rule, and the way to do this is to write what you want, which is dA by dt here, and that's equal to what you already know multiplied by some link. So we want dA by dt, we already know that dr by dt is equal to 5, so that goes here. We need a link here, the missing derivative, similar to what we were doing here. So I need a dA here. There's no dr here, there is there, so that needs to cancel out. So that's the missing derivative. Now dr by dt is 5, and dA by dr was 2 pi r. At the instant when r is equal to 3, dA by dt is equal to 30 pi. Example 4. A formula for volume and surface area is given. If we differentiate both of these, so that's volume as a function of radius, so dv by dr, surface area as a function of radius, ds by dr, we get these. dv by dt is given, and we have to work out ds by dt. So using the same relationship as before, now what we want is ds by dt, so that goes here. We already know dv by dt, that goes here. And the links, well, we can have any multiple of derivatives as we want. So we've got 1, 2, 3, 4 derivatives. So 2 will go here, and then we need another 2 here, like so. And just to check, this doesn't work. We've got a dv there, another dv there. There's no dv on the left hand side, these haven't cancelled. And then we've got a dr, another dr there, so they've multiplied. There's no dr on the left hand side. This doesn't work. We need to flip over one or more of these derivatives to make the chain rule work. If we flip over this derivative, then we have that dv cancelling with this one, that dr cancelling with this, then we're left with ds by dt, which is what you have on the left hand side. That's correct. So substituting in, dv by dt was 6, we have dv by dr, but we have to flip that over for this part. ds by dr we already have, that's 6 pi r from here. Simplifying gives this. Proportionality relationships. So dn by dt is directly proportional to n, where n is positive because we've got an increase in this example. K is the constant of proportionality. Now dn by dt is directly proportional to minus n because we're looking at a quantity that's decreasing. So we put a minus here, and then introducing the constant of proportionality, we have this relationship. Newton's law of cooling. So we have the temperature of an object and background temperature, like room temperature, and the difference between the temperature of the object and the background temperature, theta minus theta naught. And the rate of change of temperature with respect to time is directly proportional to that difference in temperatures. And then introducing the constant of proportionality and writing a differential equation. And because the temperature will be falling, we need a minus here. We have a spherical balloon, and the rate of change of its volume with respect to time is given by 5 meters cubed per second. And this is the aim, to find dr by dt, the rate of change of the radius with respect to time at the instant when the radius is 4 meters. Okay, so we need to find derivatives. What we want is dr by dt, so that goes here. We know that dv by dt is 5, so to work out the missing derivative, there's a dr on the left, so we need a dr on the right. There's no dv on the left, so we need to eliminate that dv by putting dv in the denominator here. The volume of a sphere is given by this formula, volume as a function of radius, so dv by dr, 4 pi r squared, when r is equal to 4, 64 pi. Now we need dr by dv, and this is dv by dr, so we have to flip this over like so, and then if we substitute 5 in here and 1 over 64 pi here, we get this. Example 6, the volume of a sphere, so dv by dr. The surface area formula, so dA by dr. dV by dt, the rate of change of volume with time, is directly proportional to the surface area. So a constant of proportionality is introduced, so we have a differential equation, and we have to find dr by dt. So we set up the chain rule, substitute in, and a is equal to 4 pi r squared. Simplifying, so r is changing at a constant rate, it's decreasing at a constant rate. For practice, try these questions.